Some more remarks about this statement here. First of all, when we proved this equation here, we calculated the c's. So the c's were just given by this sum here, and if we normalize our basis functions in the first place, so if we say the psi nu alpha have norm 1, then all these c's are just 1. Okay, and now we would speak of these psi's here, these psi nu alphas, as functions with special symmetry properties, because they transform in an irrep of our group. And now we can go ahead and take arbitrary functions in our vector space and write them as linear combinations of functions with these special symmetry properties. And we would usually do this in 2 steps. So let's first consider say our psi, and then apply one of these unitary operators A, and maybe apply all these unitary operators. So A in our group, and collect these and consider the span of that. That's a subspace. Let's call it U. And if the group is finite, then this is a finite dimensional subspace. And in particular, this subspace is invariant under our group G, because we just made it that way, that we never leave it by applying the group elements. And the psi itself is in this subspace. And now we can write this subspace, say, as a direct sum of invariant irreducible subspaces. Irreducible invariant subspaces. And then we introduce basis in these irreducible invariant subspaces. That's just the psi mu alphas. And then we can expand our arbitrary psi in terms of these special psi's.